We last spoke in February at Mobile World Congress, where you talked us through some of your updates there. What have you brought to this show now towards the end of October, a few months later?
Right. So the good news is that we 40 gig platform based on ATCA has become a reality. So we're shipping products based on 40 gigabit Ethernet, backplane connectivity. We have a close relationship with Cavium, and we extend our portfolio on the Cavium architecture. So primarily multi-core network processing, in combination with some of the software features needed for packet gateway applications, such as deep packet inspection. There's a variety of time scale to be needed to be integrating software packages on your own. So we extended the commercial off-the-shelf approach by framing some of the software work together with Cavium to provide it to the market. And we have a demo here at the show where we're actually demonstrating deep packet inspection on a live demo in combination with x86 and Cavium to see how quick we can bring customers to the market in a short period of time.
So just maybe just to remind people what some of the applications are of your technology within networks, and then how putting these packages in extends that.
Right, so basically the framework is Advanced Telecommunications Computing Architecture. This is the hardware framework for platforms which are going into the MME applications, LTE type of platforms. And going with LTE and packet gateway applications, deep packet inspection becomes a crucial portion for that. So besides the multi-core architecture and the high bandwidth for 40 gigabit Ethernet to the backplane and to the I/O, the software portion is still a significant portion to work on to do deep packet inspection on the platform. So the framework what we created together with Cavium is a platform called TurboDPI, which is running on multi-core architecture to be best optimized to shorten the time to market for our customers.
Yeah, so I suppose the obvious question is, taking this approach to DPI, what advantage that gives operators over the other DPI engines and providers that they've got at the moment?
Right. So some of the applications you can see for DPI is, besides the wireless applications, the LTE applications, is, for example, content insertion. So content delivery, content insertion, content instruction, load balancing also, to be optimized in a standard-based hardware architecture to maximize the application bandwidth for the end user. By the end of the day, it's coming down to the quality of service to the end user in order to enhance the user experience.
Okay, so these are the products that we'll see that we're looking at now on the stand that you're talking about.
Correct. So this is basically a framework for telecom equipment manufacturers who can leverage on what has already been done, and then focus on the application on top of that, not so much on the deep packet inspection architecture or algorithm itself, because it's already existing, while reinventing the wheel. So we're basically providing that package in order to get them to the market much quicker and much faster to revenue.
Mm-hmm. And did you mentioned that x86 RAMs? Is that a new thing or what for you?
Yeah, so there's some work ongoing with x86 with Intel-based architecture, also multi-core. We're leveraging some of the work in combination of Cavium and x86 or Cavium and Intel to do packet co-processing. So the demo what we will be seeing is a combination of both. So you have a Cavium platform and an Intel platform, and basically where the Cavium platform is doing the load work on this platform to do packet inspection and pass dedicated packets to the x86 architecture, who does then the rest of the processing on the platform itself.
And where are you seeing the most interest in your products at the moment? Is it following LTE deployments or EPC upgrades? Or?
It is primarily the LTE deployment direction. So the EPC architecture itself. So from a large scale, full scale 19-inch rack with multiple blades down to a lower level with, let's say, up to 2 blades to a smaller scale. But it's not limited to it. So you can also have some of the content delivery platforms for, let's say, IPTV and so on, where this multi-core architecture also can play a role for content insertion, like advertising and so on, to basically stream high bandwidth content to the end user.
So in that instance, you're actually looking at sort of revenue-generating opportunities for operators?
Correct, for operators and for the telecom equipment manufacturers. So revenue-generating means also time to market. So there's only a certain window of getting this platform into the market and into the network. When you talk about, for example, IPTV deployment, there's a crucial path of getting that to the market. Also mobile content delivery onto your mobile devices. The increase of the iPhone becoming available in the market, and overall usage case, you have so many end-user devices with IPv4 introduction and so on for LTE. There is a significant time-to-market advantage if you already use some prepackaged combinations on a platform level to provide deep packet inspection, for an example, to actually get to the revenue much quicker. For the carriers, it's obviously the new challenge to sustain the quality of service for all these different devices. And the telecom equipment manufacturers, with our hardware in combination with some of our software, can provide that in a timely fashion.